Very good morning. Today we are going to see a problem on node and a nodal analysis. Take down this problem. Find the node voltages for a given circuit. So this is the circuit that is shown. There are two nodes are there. Clearly in the problem itself given how many nodes are there. So just we need to frame the equation and we need to find out the what is the V1 and V2 and as well as the current. So here, this is the zero potential that V1 and V2. Say for example, current is coming like this. Okay, coming like this. If you consider I1 like here, okay, this is I1. So I1 is here, and this is the I2, and this is the I3 like that. If you consider, you can either consider whatever the direction it might be, but you need to frame the equation correctly. That is the main thing. Now we consider I1 here, I2 here, I3 here. Now framing the equation, applying the KCL at the node number 1. Okay, this is the node number 1. So we are applying. So that is nothing but, say for example, 5 volts is coming inside. Okay, 5 volts is coming inside. So 5 is equal to I3 plus I1. I3 plus I1 or I1 plus I3. So I1 what? What is I1? I1 can be write like V1 minus V2 divided by 4. V1 minus V2 divided by 4 plus what is I3? I3 can be like V1 minus 0 divided by 2. Yeah, V1 minus 0 divided by 2. Next, taking the common LCM. So multiplying both sides by 4. So we can get 20 is equal to V1 minus V2 plus 2 into V1. So further simplification, we get 20 is equal to 3 V1 minus V2. Take this as equation number 1. Similarly, applying the KCL at node number 2. So node number 2, if you apply, so here we can write this 10 amperes is coming like this. So 10 plus, okay, 10 plus I1. So 10 plus, this is also coming inside, this is also coming. So 10 plus I1 is equal to, okay, so I2 plus I2 plus this 5 is going outside. So this current is going outside, this 5 also going outside. So 10 is coming inside, okay, and I1 also coming this side to this towards this particular. So I1 plus 10 is equal to, this is going outside, that is I2 plus 5. Okay, so that is what we have. I1 plus 10 is equal to I2 plus 5. Now we need to frame the what is I1, or otherwise first we'll simplify. 10 minus 5 is equal to I2 minus I1. What is I2 here? So I2, how to write I2? I2 is nothing but V2 minus 0 divided by 6. Next minus I1. I1 what? What is I1 here? V1 minus V2 divided by 4. Then V1 minus V2 divided by 4. So multiplying by common. Okay. So 6 and 4 common multiply is 12. So taking LCM, that's all. So if you take LCM and then further simplify, this will becomes 60. Okay. 60, 12, 5 is 60, and 2 into V1 minus okay, 3 into V1 plus here minus into plus 3 into V2. So further simplification, 60 is equal to minus 3 V1 plus 5 V2. Take this as equation number 2. So two unknowns are there. So just take your scientific calculator, take unknown equation as 2, and you can further solve. Then we can get to V1 is equal to 13.33 volts, then V2 is equal to 20 volts. So this is the voltage V1 and V2. That is the nodal voltage. Now we are finding out what is current I1, I2 and I3, because we consider no I1, I2, I3. So I1 is equal to from this circuit. What is I1? So this is I1, V1 minus V2 divided by 4. So that is what I1. So I1 is equal to V1 minus V2. So just to be having V1 and V2, just substitution divided by 4. Next, but further simplification, we get the answer as minus 1.6675 amperes. Similarly, I2. So what is I2? I2 is this direction. So V2 minus 0 divided by 6. So V2 minus 0 divided by 6. So V2 already, 20 divided by 6. Minus 0 divided by 6 is equal to 3.33 amperes. Similarly, I3. What is I3? I3 is this side. V1 minus 0 divided by 2. That's all. So V1 minus 0 divided by V1 already 13.33 minus 0 divided by 2 is equal to 6.665 amperes. So this is the correct. I1 is equal to minus 1.6675 amperes. I2 is equal to 3.33 amperes. I3 is equal to 6.665 amperes. So this is the answer for this particular problem shown in the figure. Thank you.